Hey guys, welcome back to another video. In this one, we're going to be looking at straight line graphs, which is basically chapter number 7. Okay, so before we start the chapter, you need to learn a few things. So let's look at them. So the first one is the distance formula. We can find the distance formula if we know the coordinates of 2 points. So if we have that, then we can find the distance between those 2 points. Okay, so if you apply this formula, d equals the square root of x2 minus x1 whole square plus y2 minus y1 whole square, you will get the distance between 2 points. If you think about this, it actually makes sense, you know. Okay, let's actually derive this. So let's say this is d, and let's draw the x and y axis. So what would this be? This would be the x, right? And this would be the y, where y equals y2, let's say y1 minus y2, and x equals to x1 minus x2, because we're just finding the difference. So this one would be x, this is x2, this is x1, so the coordinates. So yeah, we know that x squared plus y squared equals to d squared, which is the Pythagoras theorem, which you may have learned in like 5th grade. So yeah, so d would be the square root of x squared plus y squared. That's true, right? So since this is a right angle triangle, and where x is x2, x1 minus x2, and y is y1 minus y2. So if we substitute that back into this equation, we get the same thing that we wrote on the slide. So that's how this is derived. It's pretty simple. So if you want to find the distance between 2 points, you use this formula. You could honestly use the Pythagoras theorem, but since you directly know what this is, this would be simpler. Okay, next we're gonna look at the midpoint formula. So if you have 2 points and you want to find the midpoint between them, you essentially have to add the x coordinates, divide them by 2, add the y coordinates, divide them by 2. So that's very simple, you know. If it's basically like finding the average, the midpoint of 2 points. So yeah, you're essentially finding the average of the x coordinates and the average of the y coordinates, and then you separate them by a comma, like, yeah. So this would be the midpoint here, and the midpoint of this line would be here. So these two were pretty simple. Let's move on. So now let's look at another important concept, which is gradients. You might have learned this as rise over run. So, but it's actually the change in y by change in x. So if it passes through the coordinates of a and b, the gradient of this would be the change in y, which is basically y2 minus y1, divided by the change in x, which is x2 minus x1. And also make sure you don't write y2 minus y1 divided by x1 minus x2, because that will mean something completely different. So make sure that these two are the same and these two are the same, of the same point, I mean. Okay, so now that's clear. Let's look at a few more things. Make sure you know that if two lines are parallel, then their gradients must be equal. So if these two lines are parallel, then the gradients must be equal, meaning the change in y by change in x throughout the whole line will be the same for both. So that's pretty simple. Now let's move on to the second point. So if two lines are perpendicular, meaning that they form like right angles, here, 4 right angles, that means the gradient will be the negative reciprocal of each other. So yeah, so if this is a line with gradient m, the gradient of its perpendicular line will be the negative reciprocal of m. So 1 by m is the reciprocal, and the negative reciprocal would be negative 1 by m. So this is what we get. So if two lines are perpendicular, the gradient will be the negative reciprocal. This is very important to know, this and this, so make sure you don't forget them. Okay, moving on, let's talk about the equations of straight line graphs. So the equation of a straight line is an equation which connects the x and y values for every point on the line. Okay, now I'll show you something. So if we find the equation of this line, every single coordinate that we find on this line will satisfy the equation. So that's what we mean by this statement. Okay, the equations can be written in two ways. The first one is the gradient intercept form, which is in the form of y equals mx plus c, where the gradient is m and the y-intercept is c. You know what y-intercept is, right? So it's basically when the value of x equals to 0 and the value of y will be something, which is c. So yeah, so it will be y equals to mx plus c. You'll use this very frequently, y equals to mx plus c. So I remember that. And then the other one is the general form, which is ax plus by equals to c. So you have to write x and y on the same side, and the constant must be on the other hand side. So yeah, and a, b, and c are constants. Okay, now that we know what equations of a straight line graphs are and how we can represent them, let's actually find out how to actually solve them. So there isn't really one way you can follow. It's just all about intuition and like the things that we know about the line. We honestly have to derive it. There'll be actually a lot of ways to solve them, a lot of information given, but you'll have to see which is the most apt one and then choose. But then there are 2 points here. We'll see what they are. So we can find the equation of a line if we know its gradient and the coordinates of any point on the line, or the coordinates of two distinct points on the line. So don't restrict yourself to just these 2 points. You just have to intuitively know what to do in order to find the equation of the line. Doesn't always necessarily have to be that you have to know the gradient and the coordinates of one of any point on the line, or two distinct points. It's all about like how you think and like how you can actually derive the equation rather than just like following the steps. So if a straight line has gradient m and passes through the point x1 comma y1, then its equation is this. So how do we know this? It's the gradient formula, and then we can just cross multiply, so we get this one. And then if you like simplify it, then you can write in the form of y equals to mx plus c. But right now we won't do that because this is much simpler, because if we have the gradient m, we can plug in the value here, and then we also know the coordinates of a point. So we can substitute this and then we can find it. So now let's work on this problem. So find in gradient intercept form the equation of the line through negative 1 comma 3 with gradient 5. So let's do that. Okay, so this is what we have, and gradient 5. So let's use the formula m equals to y minus y1 divided by x minus x1. This implies that phi equals y minus 3, because we have the value, divided by x minus of minus 1. So we get 5 equals to y minus 3 divided by x plus 1. Now let's cross multiply it. We get 5x plus 5 equals to y minus 3. So y minus 3 equals to 5x plus 5. And then if we solve this, write in the gradient intercept form, we get 5x plus 8. So this is our final answer in gradient intercept form. If this is clear, let's move on to a few questions. So the first question, we'll solve it together. So in gradient intercept form, find the equation of the line passing through this point with gradient 5. So now let's work on this. So we know the formula of y minus y1 equals to m into x minus x1. Now let's plug in the values. So this will be y minus of minus 3, and then m would be negative 5, and x would be 7. So now let's simplify it. So this is our answer. Let's verify if that's actually the answer. Yes, that's what we also got. So now let's solve the next one. So same formula. So y minus of minus 2 will be plus 2. Negative 3 into negative of negative would be plus. So now let's simplify this. So this is our answer. Let's see if, yeah, so it's negative 3x, negative 5. Let's solve the last one. So this is our answer. Let's solve the next few questions. So in general form, find the equation of the line passing through this one. So we have to find in general form, which is ax plus by equals to c. So now let's use the same formula in the start. So that will be y minus 0. So let's just leave that. And then negative 1 by 3 into x minus 5. Let's cross multiply. So that will be 3y equals to negative x plus 5. So x plus 3y equals to 5. That's the answer to the first one. Yeah. Let's solve the next one. Same formula. Plus 3 because negative equals to negative 2 into x minus 5. Let's expand this. And then let's bring the x term to this side, so 2x plus y, and then this to this side, equals to 7. So that's our answer. Yes. And now let's solve the final question. So y plus 2 equals to 6 into x plus 7. And now let's simplify this. Let's solve the last set of questions. So we have to find the equation of the line passing through the following points. So yeah, let's do that. All right. So we have to find the equation of the line passing through this. So yeah. Okay, so we have the coordinate of the point A and B. So first let's find the gradient. So the gradient is the change in y by change in x, So negative 2, negative of negative 2, divided by 4, minus of minus 1, that is 0. So let's use one of these points to find the equation. So y plus 2 equals to 0 times x plus 1. This will be 0, so y equals to negative 2. That's our equation. Yeah. So now let's solve this one. Let's find the gradient first. So 1 minus 0 divided by negative 3, negative 2. That's 1 divided by negative 5. So y minus 0, we'll just leave that. So that's negative 1 by 5 into x minus 2. Let's simplify this. Let's cross multiply to actually simplify it. And that's our answer. Yeah, so they added a gradient intercept form, which is this, or you can write it in this form also, general form. So now let's solve the final question. The gradient will be 2 divided by 4, because 2 minus 0, 3 minus minus 1. That's 1 by 2. Let's use this coordinate. So there is no y coordinate, so that will be y equals to 1 divided by 2 into x plus 1. That will be y equals to 1 by 2x plus 1 by 2. This is in gradient intercept form, and let's write in the general form. So x minus 2y equals to 1, negative 1. That's general form. Yeah, we got our answer. Moving on to the harder questions. So yeah, let's work on this. So we have to consider the following points, which is P with coordinates negative 2, negative 3, negative 2, and Q 1 by 6. So a line perpendicular to this line passes through Q. Okay, so now we have to find the equation of the line. Okay, now you can see that we haven't really been given any information in terms of this slide, right? So you have to think about it intuitively. We don't know the gradient, we just know a few things, which is not really, in this slide. So now let's just think about what we can do. Okay, let's see what we've been given. So we know that a line is perpendicular to PQ. So this implies that whatever we find, the gradient that we find here is going to be the negative reciprocal of the gradient of the perpendicular line. So now let's find that. Okay, so now let's find the gradient. So the gradient would be 6 negative negative 2 divided by 1 negative of negative 3. So that's 8 by 4, which is 2. So now that we have 2, we have to find the negative reciprocal in order to find the gradient of the line we're trying to find. So the negative reciprocal would be 1 by 2. So this is the thing. And then it also says that it passes through Q. So now we have the following details: the gradient and a line and a point. So now let's just use the regular formula that we always use. Okay, now let's work on the next question. So we have to find the coordinates of the point where the line cuts the x-axis. So when it cuts the x-axis, the value of y will be 0. So when we plug y equals to 0, we know this states that x will be plus 13. So the coordinate would be 13, comma 0. So now let's check if that's the answer. Yeah, this is question number 1, question number 2. So yeah, the next question states that states the following. Suppose A has the coordinates of -7, 4 and B has coordinates of 3, -2. A line parallel to AB passes through C, which is 5, -1. We have to find the equation of the line. Okay, so we know that if a line is parallel to another line, the gradient will be the same. So now let's find the gradient. 4 minus of -2 divided by -7 minus 3. So that's 6 divided by -10, which is 3 by -5. So the gradient of the parallel line will also be the same. And we've been given that it passes through C, which has coordinates of 5, -1. So y plus 1 equals to 3 divided by -5 into x minus 5. So let's cross multiply. So 5y plus 5 equals -3x plus 15. So let's do this. Let's simplify. So this is, yeah, so this is, okay. Okay, so this is our equation. Okay, now we have to find where it cuts the x-axis. So when x equals to 0, then we find the point where it cuts the x-axis. So let x equals to 0. So 5y equals to 10. Okay, so 5 will be 2. Therefore, the coordinate would be 0, 2. Okay, let's check our answer. Yes, this is also what we got. Okay, now let's look at perpendicular bisectors. So we've already looked at finding the midpoint of two points, and yeah, and also we have looked at what perpendicular lines are. So a perpendicular bisector is a line which is perpendicular and cuts a line segment into two equal parts. So if we have the points A and B, the perpendicular bisector of AB would cut AB in such way that AM equals to MB. So a perpendicular bisector involves a combination of finding the midpoint and then finding the gradient of the perpendicular line and so on. So yeah. So first I will explain how to actually find the equation of a perpendicular line, and then we'll actually move on to working out the examples. Okay, so first let's read the statement again. The perpendicular bisector of AB is a line which is perpendicular to AB and passes through its midpoint M. So what you're supposed to do first of all is find the midpoint by finding x1 plus x2 divided by 2, comma y1 plus y2 divided by 2. So when you find the midpoint, we have one coordinate. So when we have the coordinate, we can find the gradient. We can find a gradient by doing the negative reciprocal of it. So now we have the gradient, we also have one coordinate, and then we can just use the normal formula that we use, which is y minus y1 equals to m into x minus x1. So when we do that, we will find the equation of the perpendicular bisector of AB. Okay, so now let's work out this example. As I told you, we're supposed to find the midpoint. So now let's find the midpoint. So m would be 3 plus 1 divided by 2, comma, negative 3, negative 1 divided by 2, which is 4 divided by 2, which is 2, and negative 2. So that's the midpoint. And now we'll find the gradient. So that would be negative 1, negative of negative 3 divided by 1 minus 3. So that's gonna be negative 1 plus 3, which is 2, 1 minus 3, which is negative 2, so negative 1. So we have the gradient, we have the midpoint. This is the gradient of the line, so the negative reciprocal of this would be 1, so m equals to 1. Okay, now that we have this, let's find, we have the midpoint and we have the gradient. Okay, now let's find the equation. So it would be, let's use a different color. So it would be y plus 2, because it's negative, 1 into x minus 2. So it would be y equals to x minus 2 minus 2. So that would be x minus 4. So this is our equation. Let's cross verify. Yes, this is what we also got. Now let's solve the next one. Okay, so now let's find the midpoint. So the midpoint of this would be the following. So 1 minus 3 divided by 2, comma 3 plus 5 divided by 2. So implies that m is, that will be negative 2, so this is going to be negative 1, and 8 divided by 2 is 4. So our midpoint is this. Now let's work out the gradient. So finding the gradient, so that's change in y by change in x, which is 5 minus 3 divided by negative 3 minus 1. This is going to be 2 divided by negative 4, which is negative 1 by 2. Therefore, gradient of perpendicular bisector, I'm just going to write PB, is the negative reciprocal, which is going to be plus 2. So we have this and we have this. So now let's find the equation. So it's going to be y, finding the equation. The equation, so it's going to be y minus y1 equals to m into x minus x1. So y minus 4 equals to 2 to x plus 1. Let's expand this. So this would be y equals to 2x plus 2 plus 4. 2 plus 4. So it's going to be 2 plus 6. So this is our answer. So always try to write it in such a manner. Over here I was supposed to write finding the midpoint, so it will be easy for you to yourself and for the examiner. Let's look at the answer, which is also the same. Okay, so if you've understood perpendicular bisectors, then I will move on to the next topic. But just remember that perpendicular bisectors is extremely important in the exam because I'm pretty sure it comes in every alternate paper. So it's pretty important. Okay, so now let's move on to the intersection of straight lines. Okay, this is very simple also. So what you're supposed to do is you're supposed to equate the values of y, and then you have to find the value of x, and then you have to substitute the value of x that you get into any one of the equations, and you'll end up with the same y value. So yeah, so and then it's basically pretty simple. So let's just look at the worked example. So they have this one and this one. So they're going to substitute this, or what you can do is make y the subject of this and then equate y and y. Or you could just substitute this into this. Either way, you're going to get the same answer. So when they do this, they're going to get 4x plus 3 into 2x negative 5 equals to 15. Upon simplifying, they get 10x equals to 30. And then when they divide both sides by 10, they get 3. And then when you plug 3 into either one of these equations, you'll get the same answer, which is 1. So the lines will meet at 3, 1. This is very simple. And then they're doing the next question. So here they're making x the subject of the equation because it's pretty simple in this case. So when they plug the value of x into the equation, they get this. Upon simplifying, they get negative 11y equals negative 22. Essentially, y equals to 2. So when you plug y back into the equation, this equation, you get x equals to negative 1. So the two lines intersect at negative 1 comma 2. This is very easy. You just have to equate them together, or you have to substitute one of the equations into the other equation, and you have to find the value of one variable. And after you get that, you can plug the value of that into any one of the two equations in order to find the intersection point. So that's very simple. And now let's move on to the questions. So let's solve the first one. Also, I forgot to mention that there's another topic which is called as intersection of a straight line and a circle, which is basically the same thing. You're just supposed to substitute the value of y into the other equation. You're supposed to solve them. For a circle, you might get either one intersection point or two intersection points. So if it's two, then it's gonna cut the circle at two distinct points. Or if it's just one, that means it's gonna be a tangent to the circle. So it's the same principle, so I did not include the slide. But we will solve one question regarding a line and a circle. Okay, so now let's solve this question. So yeah. Okay, first let's read the question. So a trapezium ABCD has vertices A, which is 3, 0, B, which is negative 2, 5, C, which is negative 4, 1, and D. So the side AD is parallel to BC. Parallel is the keyword. And the side CD is perpendicular to BC. So we find the area of the trapezium. So if AD are parallel, that means, okay, first let's just, draw the axis and let's just plot the points so it's much easier to understand the question. So 3, 0 would be somewhere here. And then let's plot B. So negative 2 approximately here, and then negative 5, let's say here. And then C is negative 4, so double of this. So here, let's say around here, and then 1 somewhere here. So, and then it says that A, okay, let's first write the coordinates. So this will be A, this is B, this is C. This is just a rough diagram. It's not very accurate. So B would probably be somewhere here, somewhere. So let's put it in red. So according to this question, the side AD is parallel to BC and CD is perpendicular to BC. Okay, so first let's find the gradient of BC. So let's do that. So we have the coordinates of B and C. So it's pretty simple. So it will be gradient of BC. Let's find it here. Gradient of BC. So if you've noticed that B is essentially the intersection point of CD and AD. So they have given us this information in order to find the equation of AD and BC in order to find B, which is the intersection. So yeah, that's what we're supposed to do. So let's do it. Gradient of BC, which is change in y by change in x, which would be 1 negative of -5 divided by -4 negative of -2. This would be 6 divided by, this is plus, so -2, which is -3. Therefore, gradient of CD is the negative reciprocal, so it's going to be plus 1 by 3. And now let's find the equation of CD. So let's do that. Okay, so we have the gradient of CD and we have the coordinate of C. So we can find the equation now. So it will be y minus 1 equal to 1 by 3 times x plus 4. It will be y equals to 1 divided by 3x plus 4 by 3 plus 1. We can simplify this to 1 by 3x plus 7 by 3. Let's call this equation number 1. Okay, and now we're supposed to find the equation of AD. So we've given that AD is parallel to BC. We found the gradient of BC, which is -3. So let's do that. Let's find the equation. Okay, so equation of AD. So we have the coordinate of A, which is 3, 0, and gradient -3. So using this information, let's find the equation. So y equals to -3 into x minus 3. That will be -3x plus 9. This is our equation 2. So now let's equate them. Equate 1 and So on equating equation 1 and 2, on equating equation 1 and 2, we get negative 3x plus 9 equals to 1 divided by 3x plus 7 divided by 3. That's negative 9x plus 27, which equals to x plus 7. So 10x equals to 20 implies that x equals to 2. When x equals to 2, y equals to negative 3 into 2 plus 9, which is negative 6 plus 9. That's 3. Therefore, D will be 2, 3. So now we have this one, which is 2, 3. A is 3, 0. B is negative 2, negative 5. And C would be negative 4, 1. Now that we know the coordinates of the point D, let's find the area of the trapezium. Okay, let me erase all these because we don't really need it. Okay, now let's draw a more accurate version of the trapezium so we can calculate the area. Okay. So this would be a little longer. And this will form a right angle, and this would be B. Okay, so now we can find the area. So the area of a trapezium is the sum of the parallel sides divided by 2 into the height. So let's say this is E, this is F, and this is G. So the area would be E plus F divided by 2 into G. Let's first find E. E would be the square root of 3 minus 2, that's 1 squared plus 3 squared. And now F is the square root of, that's 2 squared plus 6 squared. Now let's find what this would be. So the square root of 1 plus 3 squared is the square root of 10 plus the square root of 2 squared plus 6 squared divided by 2. So that term would be 3, that would be 3 root 10 divided by 2. Now let's find G. So the value would be the square root of 2 minus of minus 4 would be 6. So 6 squared plus 3 minus 2, 3 minus 1, which is 2 squared. So the square root of 6 squared plus 2 squared is 2 root 10. Now we have to multiply this into this. So 3 root 10 divided by 2 into 2 root 10. This and this get cancelled, so that will be 3 into 10, which is 30 units squared. So That's our answer. So let's solve the next question. So we have this question. So the line x plus y equals to 7 meets the curve x squared plus y squared equals to 29 at A and B, and find the distance between A, B. So first, let's do this. We're writing this in terms of y, making it the subject of the equation. Now let's plug this into the second equation. So let's simplify this. X squared plus 49 minus 14x plus x squared equals to 29. So 2x squared minus 14x plus 20 equals to 0. So x squared minus 7x plus 10 equals to 0. So this would be x squared minus 2x minus 5x plus 10 equals to 0. This would be x minus 2 into x minus 5 equals to 0. Therefore, x equals to 2 or x equals to 5. These are the two intersection points. And now let's find the value of y. So y equals to 7 minus x. So this would be 7 minus 2. This would be 5. So let's say A is 2 comma 5 and B would be 5 comma 2. So therefore the distance between them would be 3 squared plus 3 squared, that is square root of 9 plus 9. That's square root of 18. Let's see the answer. Yeah, square root of 18 units. So therefore we got it right. Now let's look at transforming relationships to straight line form. So sometimes the variables x and y may not be related linearly. Some examples include y and x to the power of 3 or square root of x. So variables like that are not related linearly. So in that case, you're supposed to manipulate a few things in order to get it linearly. So even if x and y are not linearly related, it is sometimes possible to use a straight line graph to display the relationship. We can do this by changing the variables on the axis. So now let's consider the following equation, which is y equals to 2 into x to the power of 2 plus 1. You know that the graph of this will be this, right? It's an upward opening parabola, and as you can clearly see, it's not linear. But then we can change the value the variable on the x-axis in order to make it a straight line. So if we wrote x squared here, and this would be y, this would be a straight line. You can see this is in the form of y equals to mx plus c, where m, or the gradient, is 2 and y-intercept is 1. You can clearly see that 0, 1. So y-intercept 1 and the gradient is 2. So you can transform them. And now let's look at the worked example. So we're supposed to find y in terms of x. So first you can find the gradient here, which would be 2, and then the y-intercept is 5. Now you can write this in the form of y equals to mx plus c, but then instead of writing x, you can write x cubed, because that's the variable on the x-axis. So if you do that, you get y equals to 2x cubed plus 5. We'll look at the next example. they have done the same thing. They found the gradient first, which is 3 by 4. And then we don't have the y-intercept, so we'll just use one of the points, and we find in the gradient intercept form by doing y minus y1 equals to m into x minus x1. So when you simplify it, you get this. Instead of writing x, you have to write the square root of x. So that's pretty simple. Now we look at how to transform this equation into a linear relationship. So first, you can apply logs to both sides. So let's do log of y equals to log of a into 10 to the power of bx. This would be log a plus log this. So we can simplify this to bx plus lga. If you see, this is in the form of y equals to mx plus c, where y is lgy, x remains x, and the gradient would be b, and the constant would be lga. So yeah, this is how you transform this into a linear one. Let's solve another question. So write y in terms of x, giving your answer in the form y equals to a into 10 to the power of bx. Alright, so first let's find the gradient. So the gradient would be the change in y by change in x. So first it would be 4 minus 3 divided by 6 minus 3, which is 1 by 3. So that will be our the value of m. And now let's use this coordinate, which is 3, 3, in order to find our equation. Okay, so y, this will be not y, it will be lgy, because on the axis it's lgy and x. So lgy minus 3 equals to 1 by 3 into x minus 3. Okay, so now let's simplify this. lgy equals to 1 by 3x minus 1 plus 3. So this will be 1 by 3x plus 2. And now let's write this in terms of y. So y will be 10 to the power of 1 divided by 3x plus 2. But then they want the answer in the form of a into 10 to the power of bx. So now let's rewrite this. So this will be 10 to the power of 2 into 10 to the power of 1 divided by 3x. 10 squared is 100 into 10 to the power of 1 divided by 3x, where a equals to 100 and b is 1 divided by 3. So this is our final answer. So we're done with this chapter, the straight line equation chapter is done. I hope that all the topics that we've covered in all the videos covering the straight line graphs is clear, and make sure that you practice a lot of questions. And yeah, keep solving past papers to improve your score, and don't forget to subscribe to my channel and give this a like.